Hello, this is chapter 7, and in this chapter we're going to be talking about shapes of molecules and ions. Now, the shape of a molecule is based on a theory which we refer to as electron pair repulsion theory. Now, in the electron pair repulsion theory, we say that the molecule will take a shape so that there is minimum repulsion between the electrons. Remember that we could have bonding electrons, in which, for example, in the BF3, we have a pair of electrons between each boron and fluorine. So the pair of electrons forming one bond will repel the other pair forming the other bond. Pairs of electrons repel each other, so they try to arrange themselves in space so that they are as far apart from each other as possible. So, for example, if we have BF3, the fluorines will try to space themselves out as far away from each other as possible, and that means it will be in this kind of shape with a bond angle of 120, for example. Now, if the central atom has a lone pair of electrons, for example, in this case, nitrogen has 3 bonds, also like boron in the BF3, but the difference is that the nitrogen has a lone pair of electrons. Now, this lone pair of electrons, they found that it will repel the bonding pairs more than the repulsion between the bonding pairs and each other. So, if there is a lone pair, all the bonds come closer to each other to give more space for the lone pair of electrons. So, nitrogen with 3 hydrogens, it still has 3 bonds, but because it has a lone pair of electrons, the lone pair of electrons will take up space. Now the hydrogens are in this kind of shape, which we call pyramidal, and the bond angle has become 107. Okay, so we have rules, and you need to remember the rules. Which molecules would be linear? Linear means their bonds are as far away from each other, so that is 180. That means that we are talking about something that has 2 bonds, and the bonds are as far away from each other. Now, remember that a double bond is regarded as a bond in this case. So, whether we're talking about double or single, if we have 2 of them, then they have to be spaced away as far away from each other as possible. So their bond angle is 180. Please notice the central atom, which is the carbon or the beryllium in this case, does not have any lone pair of electrons on it. So if we have 2 bonds or 2 double bonds, and there is no lone pair on the central atom, then the shape will be linear and the bond angle will be 180. Why? For minimum repulsion between the bonding pair of electrons. Do we understand that? Okay. What if something has 3 bonds? No lone pair on the central atom. Then this is how it will be spaced. This is called trigonal planar. Remember, we said whether it's a double bond or a single bond. So in ethene, the carbon is regarded as having 3 bonds. One with hydrogen, and a double bond with the next carbon. So these are 3 bonds coming out from the carbon. So they will also be spaced so that they are trigonal planar in the shape of a triangle. And that means their bond angle is 120. So any atom with 3 bonds coming out of it, no lone pair on the central atom, this will be shape trigonal planar, bond angle 120. Can we understand that? Okay. Which ones are nonlinear? Now, if it has 2 bonds like water, but the central atom has lone pair of electrons on it, so whether it is 2 lone pair of electrons like oxygen and sulfur, or 1 lone pair of electron, we call them nonlinear. But if we have 2 lone pairs, remember that we said the lone pairs repel more than the bonding pairs. So oxygen in water has 2 lone pair of electrons on the central atom, and we have 2 bonds. That will be in a non-linear shape, bond angle 104.5. The same with H2S, because sulfur is also in group 6. It's going to make 2 bonds with the hydrogen, so it has 2 lone pair of electrons. These need space. These repel the bonding pairs of electrons, and the bond angle is 104.5. With respect to SO2, when we do double bonds with each of them, the sulfur still has 1 lone pair of electrons, so that takes up less space than the 2 lone pairs, so less repulsion between the lone pair, 1 lone pair, and the bonding electrons. So this has a bond angle of 120. All of these are called non-linear or V-shaped sometimes, or bent. So it's either actually non-linear, V-shaped, or bent. Okay, which ones are pyramidal? Pyramidal is if I have the central atom has 3 bonds and a lone pair of electrons on the central atom. So ammonia, for example, has 3 bonds and a lone pair. Phosphorus is in the same group, so if it forms 3 bonds, it will still have a lone pair of electrons. Another one that is similar to it is the hydronium ion. We said the hydronium ion has oxygen making a dative bond with one of the hydrogens, so it now has only 1 lone pair of electrons and 3 bonds. All of these, the shape is called pyramidal because it looks like a pyramid. And the bond angle between them is 107 degrees. Which ones are tetrahedral? Tetrahedral if you have 4 bonds, no lone pair on the central atom. So I want to space out the 4 bonds as far away from each other for minimum repulsion between the bonding pairs of electrons. Then it will have to be in this shape in which there is a pyramid and one on top. This is called tetrahedral. The bond angle is 109.5. The same for the ammonium ion. The central atom has 4 bonding pair of electrons and no lone pair on the central atom. Are you noticing how I'm explaining? So if he says, why does the ammonium ion have tetrahedral structure? Well, because the central atom, nitrogen, has 4 bonding pairs of electrons and no lone pair of electrons on the central atom. So for minimum repulsion between the bonding pair of electrons, it has this shape with this angle. Okay? Okay, if something has 6 bonds, like SF6, then this is what we call octahedral. Octahedral means I have 4 on the same plane in the shape of a rectangle, and then 1 on top and 1 below. All of these have bond angles of 90 degrees. That is called octahedral. So when do we have octahedral? The central atom has 4 bonding pairs of electrons, 6 bonding pairs of electrons and no lone pair on the central atom. Trigonal bipyramid. When are we trigonal bipyramid? If we have 5 bonding pairs and no lone pair of electrons on the central atom. Remember that the electrons that we add that are not used for bonding are called lone pairs. If it is bonding, then it is bonding pairs. So PCl5 has 5 bonding pairs of electrons between the phosphorus and the chlorines. They are arranged so that there are 3 on one plane, so that is a bond angle of 120, and 1 on top and 1 below with bond angles of 90. You have to memorize these bond angles and you have to remember which is which. Okay, square planar is when I have 4 on one plane and I have 2 lone pair of electrons. So xenon, if you remember, xenon is a noble gas. It's not supposed to make bonds according to what we've been saying in O level, but actually it does make bonds. So this is one molecule that the xenon makes with 4 fluorines. It had 8 electrons, so it used 4 of them to make bonds with the 4 fluorines. Now it still has 4 more, which are 2 lone pair of electrons. So these 2 lone pairs of electrons will be arranged 1 on top and 1 below. This structure is called square planar and the bond angle is 90 degrees. Okay, bond polarity. What is bond polarity? Bond polarity is due to the difference in electronegativity between atoms in a covalent bond. So we said a covalent bond means they're sharing a pair of electrons or 2 pairs of electrons or whatever. But if one of them is more electronegative than the other, then the electrons will not be shared equally. So first of all, what do we mean by electronegative? Electronegativity is the ability of an atom to attract the electrons of a covalent bond to itself. So they found that as we look at the periodic table, some atoms are more electronegative than others. So the most electronegative element in the periodic table is fluorine. Can you see that? The numbers given are an indication of the relative electronegativity. So we give fluorine an electronegative number of 4. Now, the next one that is less electronegative than fluorine is oxygen, and then chlorine, and then nitrogen. Can you see that? So Most electronegative is fluorine. You have to memorize that. And then oxygen, chlorine, nitrogen. Everything else is not regarded as electronegative because the electronegativity is very small. Okay, so if we're talking about, if you're looking at the periodic table without any of these numbers, you should realize, look at the periodic table. Fluorine is the most electronegative, then oxygen, then chlorine, then nitrogen. All the others are less electronegative, and in many cases we regard them as not electronegative. So in bonds between different elements, the element with the higher electronegativity attracts the electron pair more strongly. So if I'm saying I have a bond between hydrogen and fluorine, well, fluorine is the most electronegative element. We give it an electronegativity of 4. Hydrogen is much less electronegative, and that means that if we have a pair of electrons being shared between the hydrogen and fluorine, these pair of electrons are not actually in the middle equally shared. No, the fluorine is electronegative, so it sort of attracts these bonding electrons to itself. So the shared pair of electrons are actually closer to fluorine than to hydrogen. And that means we say that the fluorine now has a slightly negative charge. Can you see the notation written above the fluorine? This indicates a slightly negative charge because the electrons are slightly nearer to it, and the hydrogen has a slightly positive charge because the electrons are slightly further away from it. So this kind of bond is called a polar bond, when you have electrons not equally shared. And when does this happen? It happens if one of the elements is much more electronegative than the other. So which of the following bonds is likely to be the most polar? Well, we look at the numbers for the polarity. Remember that we said between something hydrogen and fluorine, that would be the most polar, because this is the biggest difference in electronegativity. So the bigger the difference in electronegativity between the atoms, the more polar the molecule is. Hydrogen is 2.1, fluorine is 4, so that's about a difference of about 2 or slightly less, 1.9, so that's a big difference. If you look at the difference between the electronegativity of phosphorus and oxygen, for example, that's a difference of 1 point something, 1.2, 1.4, 1.4. Nitrogen and chlorine, that's the same actually, approximately the same electronegativity. Carbon and sulfur, between carbon and sulfur, no difference. So the one that is most polar is the one that has the bigger difference in electronegativity. So in this case, it's HF. The type of bond between the atoms depends on the difference in the electronegativity between the atoms. So if one of them is more electronegative than the other, then this is a polar bond, because we said between hydrogen and chlorine, you have a difference of about 1 or 0.9. So chlorine is more electronegative than hydrogen, so this is slightly electronegative. Now, between sodium and chlorine, this is a big difference in electronegativity. So when we have this big difference of electronegativity, this is where we refer to it as ionic, because in this case, the electrons are not just slightly attracted to the chlorine. No, it is totally taken by the chlorine because the sodium has very low electronegativity. So when there's a huge difference between the electronegativities of the atoms, then the bond is referred to as ionic, because the electrons are completely removed from one and given to the other. So if we have a bond between two similar atoms, even if both of them are electronegative, but they're similar, so they will attract the bonding pair of electrons equally to themselves. So this is called a non-polar covalent bond. If one of them is more electronegative than the other, then that one will attract the electrons towards it more than the other one. So it will have a slightly negative charge and a slightly positive charge. So that is called a polar covalent bond. If the difference in electronegativity is huge, then the electron will not just be attracted towards the nonmetal, it will be given completely to the nonmetal, and this is where we have an ionic bond. Do we understand? So the degree of, or the difference in electronegativity determines whether this is a non-polar covalent or a polar covalent or an ionic compound. So a compound is, okay, that's when we're talking about just two elements in the compound. But in some cases, a compound is polar only if there is net polarity. For example, the water. water we refer to as a polar compound. Now, why is it a polar compound? Because the bond between hydrogen and oxygen is polar. Oxygen is more electronegative than hydrogen. It attracts the bonding electrons to itself. Now, the other oxygen and hydrogen bond also, the bonding electrons are attracted to the oxygen. So that means I have a net polarity, and that means that that compound overall is polar. Now, what if we look at this kind of compound, H2CO? If we're looking at the bond between carbon and oxygen, the oxygen is much more electronegative than the carbon. There is net polarity, so this compound overall is polar. Do you understand? So there is a difference between the bond itself is polar or the overall compound is polar. So in water, the bonds are polar and the compound is polar. In H2CO, the bond is polar and the compound is polar. But if we look at carbon dioxide, now each of these is polar. The bond between each carbon and oxygen is polar, but they are in opposite directions, so overall this polarity cancels and overall carbon dioxide is non-polar. Do we understand the difference? So if we're talking about the CO bond alone, each of them is polar. But because in the compound the polarity is cancelled, then the compound as a whole is not polar. So again, another example, we have something called CHCl3. Now, if we look at CHCl3, the polarities go down in all of them, and the carbon-hydrogen bond is not polar, so there is a net polarity, so that compound is polar. But if we look at CCl4 with 4 carbon-chlorine bonds, each of them is polar, but then they go in opposite directions, so they cancel each other, so the compound overall is not polar. So if a compound has an overall polarity, how do we know if this compound is polar or not? It will have effect on the electrostatic force, or I can put it so that it is attracted to an electric charge from a polar compound. Which of these molecules is polar? Again, if we look at these molecules, you want first of all to have a difference in polarity. So remember that CH4 is not regarded as polar. CO2 is not polar because the polarities cancel. CCl4 is not polar as a whole because the polarities cancel. So the only one that is polar in this case is ammonia, because ammonia has net polarities going up, because each of these bonds is polar and they don't cancel. Okay. Sulfur can combine with fluorine to form a number of different compounds, some of which are shown below. From the diagram, which compound will not be polar? Again, if it's not polar, that means that the polarities are in opposite directions and they cancel. That's the one for SF6. The other ones, they don't cancel each other. Okay, so this is the end of this chapter. Please sit down and study. Try to think about each molecule and what its shape and bond angle would be.